So you've seen AIs do some pretty amazing things, right? Like pull data from thin air or crunch numbers in an instant. Well, it's not magic. It's all about giving them the right tools. Today, we're going to pull back the curtain and actually build one of these tools, step by step. You'll see exactly how it's done.
Hey everyone! From all of us here at Dev Credence, welcome to The Explainer. We're all about taking tricky tech topics and making them super simple.
And today, we're diving deep into a really core concept from the Model Context Protocol. You might know it as MCP. Think of this as the fundamental blueprint for giving AI agents actual, real-world skills.
All right, let's get our hands dirty. What are we actually building? Something simple, but trust me, it's powerful. We are going to create a math server. Basically, a little calculator that an AI can use whenever it needs to add two numbers. Simple, right? But the pattern is everything.
Okay, here's the entire code we're going to break down. I know. Seeing it all at once can look like a lot, but don't sweat it. We're going to go through this piece by piece, and I promise by the end of this, it'll all make perfect sense. It's like building with Legos, one block at a time.
So, first things first. Every tool needs a home, right? A place to live. In our world, in the MCP world, that home, that workshop, is the server. So that's where we have to start. And here it is, our very first line of code. Super straightforward. We're just creating a new MCP server. We give it a name, math server, and a version. That's it. Think of this as setting up the main workbench. It's empty for now, but it's ready to hold all the amazing tools we're about to build.
So what exactly is this MCP server thing? Well, it's the boss. It's the general manager of our whole operation. It's a thing that keeps all our tools organized, knows what they do, and makes sure the AI can actually find them and use them when it needs to. It's the brain of the workshop.
All right, the workbench is ready, the lights are on. Now for the fun part. Let's actually build our very first tool. This is where we give our AI its first real superpower.
So, to define a tool, we use the server.tool method. And it's basically a simple three-part recipe. Seriously, just three things. 1, you give it a name. In our case, add. Easy. 2, you tell it what ingredients it needs. We call this the input schema. And 3, you write the instructions for what to do with those ingredients. That's the logic function.
Okay, let's zoom in on that second part for a second, the schema. We're using a cool library called Zod for this. And let me tell you, this part is so important. Why? Because it's like a bouncer at a club. It creates a strict contract. It tells the AI, look, if you want to use this add tool, you have to give me two numbers. Not one, not three, not a word, two numbers. This is what makes our tools reliable and stops things from breaking.
And this is what that bouncer's guest list looks like in code. See? We're saying we expect an A and it has to be a number. And we expect a B and that also has to be a number. It is crystal clear. There's just no way for the AI to get it wrong, which is exactly what we want.
Okay, so the AI showed up with the right stuff. Our Zod schema, our bouncer, let it in. Now what? Well, now it's time for the main event. This is where the logic kicks in, the part of the tool that actually does something. And here it is, part 3 of our recipe. It's this little async function right here. You can see it takes in our inputs, A and B. And remember, we already know their numbers because Zod checked them for us. This little block of code is the engine of the tool. It's where the magic, the actual addition happens. So just to spell it out, this function has a simple 3-step job. Step 1, it gets the inputs, A and B. Step 2, it does the work. It adds A plus B. Step 3, it wraps up the answer neatly and hands it back in a format that the AI can understand. That's it. Input, process, output. Classic. Okay, check it out. We've built our workshop, we've crafted our first tool, it's all sitting there ready to go. So what's left? We just need to plug it in and flip the switch to bring it all to life. Now the way we do that is with this thing called the Studio Server Transport. Yeah, I know, it sounds super technical, but its job is actually dead simple. It just tells our server how to talk and listen. Studio, or standard input/output, is basically the most direct way a program can communicate. It's like it's listening for text messages and sending text messages right back.
Actually, let's make it even simpler than that. The best way to think about it is like a private hotline. It's a direct, dedicated phone line between our tool server and an AI agent that's running on the same computer. No internet, no complex network stuff, no firewalls, just a clean, instant connection. And this final chunk of code, this main function, this is the glue. This is what connects everything we just built. It sets up that hotline we just talked about, and then it calls server.connect. And that's it. The server is officially open for business, listening for calls from the AI.
So let's just do a super quick recap of the blueprint we've put together. We've got the MCP server, that's our manager. We've got server.tool, that's our 3-step recipe for making any tool. We've got the Zod schema, that's our strict bouncer for the inputs. And finally, the Studio server transport, that's our private hotline. Those 4 pieces are the whole game.
And that's it. You just build a fully functional, AI-ready calculator. But here's the really cool part. This exact same pattern, this blueprint, can be used to connect an AI to pretty much anything. A database, a website's API, your smart home devices, you name it. The point is, you now have the fundamental pattern. The only real question left is, what are you going to build next?